So how do you determine whether this and also there are certain
these documents are what kind of format?
yes.
Good afternoon, ladies and gentlemen. Welcome to iCreate Mobility Challenge 2012 Award Ceremony. I would like to invite Mr. Jeffrey Tay from Center of Instructional Technology to give the opening address. Please welcome Jeffrey.
Good afternoon, everyone. Thank you for coming today for the iCreate Award Ceremony. Okay, I believe it has been an exciting 2 months for all the students out there that have been working hard to get all the apps out. I know I've been quite bad on you guys today, working on asking your weird questions. Yeah, okay. The whole reason for that is I want you guys to think about what you want to do with the app. You guys spent 2 months working on something that's quite incredible, very fantastic. So moving on, what are you going to do with it? Are you going to just leave it alone, cast it away, so in the storeroom, or you'll continue developing it, getting other people to use it? So that's why actually I believe I went around asking a lot of you, what's the one thing that's special about your app? All right? I'm quite happy that most of you guys told me something that was heartfelt. It's done by students for students. It's an intuitive app that fixes a lot of problems that as a corporation we can't solve. It's social. You can use it anywhere. And it's also this very popular thing of being offline, where you can be on the bus, you have no 3G access, you have no Wi-Fi. You can still do what you're doing without worrying about connectivity, which is what I'm very happy about, because end of the day, we cannot guarantee connectivity. So offline is a very important issue that we need to address. Okay? I have good news to tell everyone. Previously, we said that the BlackBerry Award is only given to those that have ported the apps to BlackBerry. I'm happy to announce, RIM is not here, I believe, that RIM has decided to give the top 5 winners the BlackBerry Award, whether or not you have ported the app. Okay, so that's why there was quite a flurry just now to get all the BlackBerries up there. So everyone gets the first to 5th prize, okay, plus a BlackBerry Playbook and a BlackBerry phone. The phone model varies, okay, but the Playbook is standard. Without much ado, I'll invite Prof. Wong to come to the stage to talk about Living Labs before we proceed with the award ceremony. Thank you.
Right, afternoon everyone. Okay, for the next few minutes, I'm going to tell you about this initiative called NUS Living Lab. It is a project that started in November last year. Okay? And let's get going. Okay, the purpose of the Living Lab is as follows. It's intended to be a major ICT, Infocom technology, and IDM interactive digital media testbed with an emphasis on mobility, education, and lifestyle solutions. It will be a managed solution so that developers can come on board and then we can work with the developers to get pilots and trials out. Hopefully, it will fill the gap between what we do at research in many of our research labs and pushing this out into industry as products and services. It will be a convenient testbed resource that the community within NUS can use, but we also invite others to come on board, including startups, SMEs, and industry partners. And hopefully this will be the model for future testbeds. You're probably wondering why I'm bringing this up, because maybe when you, at the end of this, it may give you some better idea about what you're going to do with your apps. So the vision behind NUS Living Lab is that we want a pervasive and extensible testbed that supports pilots and trials at scale. So you're not talking about pilots and trials inside the lab. We're going to do pilots and trials across the whole campus within a community of 40,000+ people if need be. All right? And I'll give you a couple of examples of things that we have already put in place that you could tap on. So the objectives are fourfold. The first is that we want to put in extensive sensing capabilities. All right? And there are various types of sensing. All right? Secondly is to provide the coordination and support, because you cannot just leave things there and then nobody takes care of it. Who do I contact? If I have problems, who do I clarify my issues and so on? It will also provide a repository for R&D, shareware, and assets. So that will be comprising 3 types of things, namely the data sets, the APIs, and the apps that are being developed. And finally, to carry out pilots, specific pilots, and we have already started on at least 3 pilots as exemplars, which will validate the testbed for others to use later. So the activities include prototyping, test bedding, and piloting, common services in a resource unit to support developers, and to outreach to other potential users and developers. So this is the framework of the testbed. The blue area is where the infrastructure is, and what you see is at the bottom down here where all the sensors are. Then you have the mobile comms infrastructure, then the APIs over here, and then applications. These are example applications. Some of them we have started, some of them we have not started. And the orange box on the side here is where the technical support lies. So let me give you 2 examples, all right? Okay. The first is on indoor localization and navigation. Now, most of you are familiar with GPS. You know, you can get your location when you're outdoors. What happens when you're indoors? All you get is perhaps you're near this building, right? In fact, what you see, if you go to Google Maps, you see this big blue circle, which is probably half a kilometer wide. So you don't really know where you are. So with our capability of sensing, we can now tell you where you are. All right. Unfortunately, I don't have a visualizer. I'll show it to you. Okay. So in this room, I can tell whether you're on the left side of the room or the right side of the room. In this room. Okay. If you use your Nix Basa, it just tells you that you're near U-Hall. That's all it does. All right. Okay. So this gives you an example. So the background is that we all are familiar with GPS, but for indoor localization, there is no commercially available technology today. So indoor localization extends location-based services to indoor environments, and I'll give you examples of what we can do with that. Apps that could benefit from that could be retailing and advertising. Suppose you're walking down a shopping mall and it knows exactly where you are. I'm sure the retailers will be very keen to know that. Okay? For security operations, if I'm OCS, for example, I want to know where are all my safety and security officers. I can do that today. Not only outdoors, but also indoors. Okay? Social media and networks. Maybe you want to know where your buddies are, and you say, let's go to the nearest canteen or whatever, you know. Okay? Outdoor and indoor navigation. So there are many techniques. I won't go through in detail. All right? Some of you, if you are in engineering, ECE or whatever, or in the CEG program, and you're keen to do internships or FYPs with me, let me know. So these are all the different techniques that people have tried. Okay, and the resolution varies from about 0.2 meters to 20 meters. Latency is the delay before you find out the location. Okay, so if you're just detecting a device that is just sitting on the table, well, you don't need very high, very low latency. All right, 10 seconds is okay. But if I'm going to track you walking down the corridor, it has to be sub-second. Because if it takes me 10 seconds to determine where you are, you're already out of the room, right? Okay, so it has to be very, of course, complexity and cost is important. Scalability is, scalability means that it is not required that every app needs resolution down to, say, 1 meter. All right, after all, if you look at Google Maps, most of the time, you're only talking about 10 to 20 meters, even in a vehicle, that kind of accuracy. All right, but if this was a virtual 3D environment and I want to know where you are sitting, then I need to have resolution down to about 20 centimeters. Okay, so different applications will require different scalability. So the thing is whether your algorithms can cope with the different scalability. Now, the important thing is we want our technologies to work on top of existing infrastructure. I don't want to put additional equipment to be able to detect where you are. All right? Okay, because that's an extra cost. So that's an important consideration. So as a result, if you can use existing infrastructure, then it's only a marginal setup cost. And that's important as far as deployment goes. Okay, so this is a little demo. This is our lab, actually. What you see on the left is the virtual figure of the actual physical lab here. All right, and we are able to do things like this today. Oops. All right, so this is a demo of the person walking down the aisle, as you can see. The blue circle is showing you his path. And we can actually track that person walking down that aisle. Now, this is not science fiction. Now, what you see in Mission Impossible and all those stuff is science fiction. Doesn't occur in real life. This is actually in our lab. If you're interested to see this, we can actually demo this to you. All right, so that requires a latency of less than 1 second. Okay, all right? That gives you some idea what we can do. Okay, so the thing is, we can use this to provide what we call last mile navigation. All right, so again, here's an example of an app that we are developing right now. Some of you may be doing something similar, and if you are and you're keen to come on board, you let me know. For example, you want directions from points off campus to destinations within NUS, say the nearest car park. You can do indoor, room to room. So for example, many of you, when you first came here, you're completely lost, going from one building to another building, one level to another level, but you're still walking on the same floor. Right? Okay? You get completely lost. So wouldn't it be nice if you have a tool that can do that? That would navigate you indoors, not just outdoors. Okay? Navigate between different floors of buildings. Textual information with distance, just as you do with any navigator. You can have turn here, go straight, etc. Ability to view different floors. Points of entrance markers like bus stops, car parks, elevators, stairs, and so on. So basically what this means is that if I can tell where you are indoors, I can navigate you in 3-dimensional space. GPS outside is 2-dimensional. Your cars cannot fly. They're all on the ground. It's 2-dimensional. For indoors, you need 3-dimensional because you're going to go into elevators, moving from floor to floor. You are going to go to stairwells, moving from floor to floor. Okay? Right? So this is an example of the kind of a mock-up interface that we have. All right, the first prototype demo should be ready by the end of this month. Okay, and what you see here is E4, E5, and Com Center. All right, okay, because that's where the team is residing. And you want to go, say, let's say, take a scenario. You're driving into campus. You want to find where is an empty parking lot. Okay, just as you go into a shopping mall, you want to see where is an empty parking lot. Today's shopping mall doesn't tell you where's the empty parking lot. It just tells you how many parking lots are there. You still got to look for the green light. Most of the time it's red. Correct? So what we want to do is to improve on that. We want to tell you where that lot is so that we can navigate you to that lot. Okay? So it needs a different technology from the laser infrared technology that you have in the shopping malls. They use infrared. You can actually try it. You go under the light and stand there. It will bounce off your head and it will turn to green light. Okay, but you must, I think the head must be pretty big. But it works, I've tried it. Okay, so the thing is the technology, ours is mainly outdoors, right? So you need the different technology. But imagine you want to do that. You are going to meet Professor X, who is in room Y. You want to find a parking lot, park the car, get out of your car and get to his office, which may cut through several buildings. Okay? So you go that and you will navigate. So outdoors, no big deal. You can do it with many navigation tools. Outdoors. The question is going indoors and the transition between outdoors and indoors. All right? So this is an example of room to room. I can navigate. Those of you who are in engineering, you know this is E4. Huh? Okay? So you park. As you can see, the blue path. And then I want to go to a particular room. I don't know which room. E4. I don't know which one. All right? Okay, you want to go to a particular room. So from the parking lot, which is the SRC parking lot over here, SRC, yeah? All right? It will navigate you along, this is Cambridge Crescent, right? YH there. Then it crosses here, goes through Com Center, goes through E5 to E4, that particular room. So you need that transition between indoor and outdoor. Okay? So that's one example. All right? So we actually have an engineering app here. I don't have a visualizer, but I can show you as I was mentioning. We can determine where you are, or not where you are, where your device is. I do not know where you are. I know where your device is. Okay? Where your device is to within 10 meters, anywhere on campus, except in embargo areas. Of course, we have to hide that now. Okay? All public areas, within 10 meters. So those of you who are doing things that requires position, think about it. If I can tell where your position, your device position within 10 meters, there'll be so many wonderful applications that you can do, which is not possible today. All right? Okay? So within this room, we can tell you, like just now when we were outside, I know I was on the linkway. Downstairs when we were down in the exhibition, I knew I was on the ground floor, level 1 U-Haul. Okay? Google Map won't tell you that. Okay? So that's one application that we have done, and it's available. It's an API call. That's it. Very simple. The second one that we have done is on crowd density estimation. In other words, we want to estimate what's the level of the congestion in a particular area. Okay? That's the aim. Okay? So there are many applications that could benefit from such a video analytic. We call this a video analytic. Okay? For example, reservation applications, social media applications, facilities planning applications, apps where you want to monitor or to direct crowds. Okay, so one of the things that we are doing right now, today, is that, and again, it will be ready, at least the prototype, by the end of the month, is, wouldn't it be nice if I can tell how crowded are the canteens? Then I can avoid the very crowded ones, right? Live information. Okay, so we are building that app. Okay, so that will be one of our pilot apps. Food outlets like food courts, queues on ticketing counters, supermarkets, exhibitions, and so on. All right? So the thing is that, of course, to do that, you need to train the system. You need to know what is background. And once you know what is background, whatever blocks the background, and it looks like a human being, you think it's a crowd. Okay, so we have algorithms that will train it. So once you train it, you can see this Arts Canteen, huh? You recognize that, right? You see all the bodies there, right? In red, huh? So we actually can tell how crowded is a place. So we're gonna launch an application later that will tell how busy is each canteen. Okay, and then you can decide, I don't want to go to the engine at 2 o'clock, 3 o'clock, you know, or 12 o'clock is too busy. So this is actually an index to tell you how busy it is. So you can see around lunchtime here, that's very busy. All right? And then it gets down again. Then around evening time, this one whole day, huh? All right? So we can actually tell. This is not a body counting algorithm. It is an occlusion algorithm, okay? Body counting means I count people. We are not counting people here. We are counting the amount of image that is blocked, that's blocking the background. So he has to learn the background, okay? So again, With an algorithm like that, we have the analytics. So what we're going to do, I already gave you one example. We're going to do it for the food outlets. Okay. Our next phase, we plan to do it for all our bus stops. See how crowded bus stops, and also on the bus. So right now, your next bus, it doesn't tell you how crowded it is. Right? Okay, I don't know whether you tried it or not. Have you downloaded it and tried it? Okay, it was just launched last week. Okay, so next version, maybe future version, you say, okay, I can actually tell how crowded is the bus. Okay, I should be able to tell how crowded is the bus stand. So if you are at Com Center, YH there, if you know it's very crowded, you want to take bus A1, you better move down a little bit lower but before the bus stop at Com Center, because you're not going to get in at Com Center. Okay, so things like that. All right. So these are the key components, and I think I'm going to wrap it up here because I've taken more than my 15 minutes. So key point is now we are putting in place data sets, APIs, and apps that you could download. ComCenter has already launched one, m.nus.edu.sg, where apps can be put there. We may or may not put that yet. We haven't decided, but we will have to decide on that at some point. Okay, because there are production apps and developer apps. I think we need to make a distinction between those two. Okay, but indeed, we will put all that available so that those of you who are keen to be developing new apps have all these facilities available to you. All right, so that's the whole aim. All right, and then maybe some of you may be able to put it in Apple Store or Google Play and then make some money. Okay, so that's the aim. All right, but to do many of these things, you will find that you do need information from the environment, and that's where we come in. All right, because of the sensors. So if you want to do some of these things, if you're looking for ideas, you want to join us in some of these new applications that we are developing, all right, let me know. Okay, and we will more than welcome you on board. Of course, if you're going to do an FYP, even better still, right? Kill two birds with one stone. All right, okay, right. With that, I think that's about it. So these are all the impact statements. And that's about it. Thanks.
Thank you, Prof. Wong, for the interesting presentation. In May this year, we invited NUS students to participate in this challenge to showcase their talent and creativity by creating mobile apps. We aim to enhance student education experience and campus life on mobile platforms. These students presented their completed applications in front of a panel of judges. Let's enjoy the video of their experience.
All the annotations, whatever.
There's a time lag. Process and we get the data from
And also from eBay as well. And the show is one time, so the refresh button is actually more than 1 point and another point. So it takes the current time.
Is there a program in the market that looks to motivator? Basically, if you dislike to a person goes, it's automatic.
As one particular pseudo item related to one.
problem. We will finish this activity.
Line of color showing where
Not just related to standards.
I mean, I don't even need to know the title of my textbook. So I'll type in and then
For you to find it, there's actually a lot of people who pay for this. They wanted to go through the admin process. So they have to add it into
the second calendar, day from 1 p.m. to 3.
all this data.
We have come to the exciting point of today's event, the prize presentation. I would like to invite Mr. Tommy Hall, Director of Computer Center, on stage to give away the prizes. Tommy, please. The fifth prize goes to App Cycles. Each team member will receive a Nova 7, BlackBerry Playbook, and BlackBerry smartphone. Representative of the team, please. App Cycles developed the app called Question NUS. This app helps the NUS community to find answers to their day-to-day life questions. Okay, the app works on all platforms, and the answer can actually be shared on Facebook. The fourth prize goes to Team Trackers. Each team member will receive a Samsung Galaxy Tab 2, BlackBerry Playbook, and BlackBerry smartphone. Representative? Team Trackers developed the app called NUS Navigator. It's an application that aims to allow students to find any place that can be possibly listed in NUS, down to the actual room of a building itself. The third prize goes to Mew. Each team member will receive an iPad 2, a trophy, a BlackBerry Playbook, and a BlackBerry smartphone. Representative from Mew? Mew developed the app called Group Notes. It actually allows anyone to collaborate with friends in real time through its fast, automatic sync technology. Oh, scary. Careful. Okay. The second prize goes to App Sync. The team will receive a $1,000 cash reward, and each team member will receive a new iPad, a trophy, a a BlackBerry Playbook, and a BlackBerry smartphone. Representative from Epsing. Epsing developed the app called Project X. It is a project management application for Android that allows teams to collaborate and get their project work done faster. Okay, now the exciting moment. Okay, the first prize winner of this challenge goes to Team Cephaloford, is it? Is that how you pronounce your name? Yeah, Cephaloford, correct. Okay, the team will receive a 2,000 cash reward, and each team member will receive a new iPad, 64 GB Wi-Fi plus 4G, a trophy, a BlackBerry Playbook, and a BlackBerry smartphone. This team developed an application called Drawcast. It is a unique approach to note-taking. It allows students to view the webcast and jot down notes concurrently, either by drawing, writing, or typing anywhere on the page. This year, we have a special prize for the team who actually got the highest SMS voting. Okay, this winner team is iFoodie. Each team member will receive a Seagate expansion external drive each. Thank you, Tommy. Congratulations to all the winners. Okay. We have come to the end of the ceremony. I would like to invite all of you for a tea reception just outside the auditorium.